Good morning, gentlemen. I am Captain Vivek Shil Srivastav, and today we'll be talking about terrestrial navigation. Now, terrestrial means Earth, right? So, navigation on the face of the Earth. Now, as you know, Earth is a sphere. So, navigating from point A to point B on the face of the Earth, how will you go about it? Now, the closest approach will be to navigate on a globe. So you can take a piece of globe and plot your courses and distances from A to B and go about it. But just realize how difficult it will be or practically impossible to actually make your plot your courses and distances on the globe. So now we always try to depict data on two-dimensional place like on piece of paper. So for navigating on the face of the earth, we need to transfer all the data that is there on the globe down to a piece of paper, two-dimensional piece of paper, so that we can navigate easily and do our calculations, plot our courses and distances. Like it will be much easier to plot a course and distance on this screen because it's a two-dimensional screen. You can draw a straight line, you can mark your distances, you can calculate angles, courses. So it's much easier and practically viable to do your navigation on paper. So for that reason, we need to transfer all the data from that globe down to your charts so that you can practically do your navigation. But now transferring that data to a chart is a little tricky. Now, if we talk about small portions of areas on the face of the earth, they can be practically assumed to be flat, almost flat, because you can see all around you that you can see the oceans all flat up to a certain range. Then the horizon, it disappears after the horizon. But once the distances increase, then the curvature of the earth becomes more prominent and your calculations regarding your courses and distances are they become difficult. Okay, so for larger distances you need to transfer these areas from the globe to the chart. Now before we go about talking about how to transfer and how to develop your charts, there is something called departure, right? That we have to understand. Now I will assume that all of you are aware of about the coordinates of position fixing, that is latitude and longitude, right? So latitude is the angle contained at the center of the earth between the observer and the plane of the equator. So you are here and so this angle will be your latitude. This is the observer and this is the equator, right? So this is the plane of the equator and the angle contained at the center. And longitude is the angle contained at the poles between the Greenwich meridian and the meridian passing through the observer. So Greenwich meridian or the prime meridian, and that will be your longitude, right? So these are the basic coordinates for position fixing on the face of the earth, right? Now, when you need to go from A to B, suppose you're traveling from A to B, A will have a certain latitude and longitude, B will have a certain latitude and longitude, right? So now the difference between this latitude and this latitude, we call it dlat or the difference in latitude. That is also you must be aware. And in the same manner, the difference in the longitude, we call it d long. The difference in longitude between two positions. Now this is important because now for understanding departure, what is departure? Okay. Now we have got latitude, longitude, delat, delong. So that must be clear to you. Let's go to what is departure. Now suppose these are two meridians, right? This is the pole and this is the equator. Now the meridians converge towards the pole. So all around the equator, all the meridians will go and converge at the pole, right? Now departure is the east-west distance between two meridians at a certain latitude. This is the departure. I'll repeat once again. It is very important to understand. Departure is the east-west distance. East-west distance between two meridians at a particular latitude. This is very important. At a particular latitude. So when we say departure, we mean departure at what latitude? Departure has to be for a certain latitude. Okay. So if you see departure at the equator, now if this is one meridian, this is one meridian, and this is the equator, what will be this arc? This will be d long. This arc will be d long between these two meridians. That is the difference in longitude. Suppose this is 60 degrees east and this is 80 degrees east. So d long will be 20 degrees, right? So here at the equator, the departure will also be this much. Now departure is in miles, not in degrees. So miles means if this is 20 degrees and you 20 into 60, okay. So 1200 miles, right? So the departure is equal to d long at the equator. And as you will observe, the distance between these two meridians keeps on decreasing as the latitude keeps on increasing. So what happens to departure? At the equator, the departure is equal to d long, and as you go up, the departure eventually becomes 0 at the pole because the meridians converge. So there is no gap between the meridians, there is no distance. So the departure is 0. So now this is very important in your terrestrial navigation going further. So understanding departure. So now you can see that departure is actually dependent on the latitude. At what latitude you are, the departure varies and it is directly dependent on the latitude. And now there is a formula for departure, how to calculate. So this is given by departure upon d long is equal to cos of latitude. Okay. Okay, so this is the relationship between departure, d long and latitude. Now as you can see that departure is dependent on latitude. Hence latitude is over here. And also since we are talking about departure between two meridians at a particular latitude, hence the d long between the two meridians is also important. So hence all the three values over here, and that this is the relationship which governs the departure between two meridians at a particular latitude. So now as you can see at the equator, d long is equal to departure. Why? Equator latitude is 0. What happens to cos 0? 1. So departure becomes equal to d long. So at latitude 0, that means at the equator, departure is equal to d long. Now departure in miles. Suppose the d long is 20 degrees, right? Departure will be 20 into 60, 1200 miles, right? Now we'll talk about the scale, how to measure distances later on, but at the equator, the departure is equal to d long. The departure in miles and d long in minutes are equal. Now, as you go up, the latitude increases. When you reach latitude 90, what happens to departure? You put here cos 90, becomes 0. So departure becomes 0, right? So the departure depends on the latitude. As the latitude increases, the departure between two meridians decreases. And as you approach the pole, the departure becomes 0. Now, just keep in mind and remember this thing, that departure is always at a particular latitude. When you say departure, it means departure between two meridians at a particular latitude. That is very, very important. Okay. So now let's go back to our this thing. Okay. Now departure, where is it used? Earlier, in olden times, people used to sail out, and they used to sail east or west, because it was much easier to sail east or west, because you can see the rising sun. You know that if this is the east direction, you can go in that direction. You know the other way is west, you can go in the west direction. So sailing in that direction was much easier, east and west, and there was a natural star to guide you. Okay, then there was the pole star, so you can know your north direction, and hence sailing east west was much easier. So what sailors used to do, the distances, they used to sail on this parallel of latitude. For example, they are sailing at latitude 40 degrees north. They will just sail on this latitude, and they will measure their distances, and that distance sailed on that particular latitude is the departure. So departure is used in parallel sailing. Parallel sailing. So parallel sailing is nothing but sailing on a parallel of latitude. On a parallel of latitude. So when you go east-west on a parallel of latitude, that is parallel sailing, and the distances are nothing but departure on that latitude. Okay. So now this is the parallel sailing, and let's go back to our idea of transferring the data from the globe to a chart, what we were talking about earlier, right? For small portions of areas, there is no problem. They can be very well much easily depicted as a flat piece of land on a piece of paper. So it's not very difficult. For example, we'll take the analogy of a orange peel. So you assume this, that the earth, or you assume it that you can strip off pieces of paper from the globe and put it flat on a board. So how will it feel like, right? So you have the equator, you have the pole, and suppose you've got slices like this, and let's extend it. Okay. Now, actually, I'm making wrong. Okay. Anyways, so now, if we try to peel off these sheets of paper from the globe and try to put it on a screen, how will they come? They will be coming somewhat like this. With the equator over here. Now this is touching, okay. So when you try to put that surface of the sphere on a flat two-dimensional screen, it comes out like this. Now there are gaps. So, okay. So now how to actually transfer? There will be islands, there will be seas. How to transfer these areas onto the sheet safely and while making it a full chart, as you know, as you have seen on board. Okay. So now in earlier times they used to have charts like this. When they did not, they used to have charts like this. The pieces of globe put on a two-dimensional plane for easy working. Okay. So so for today that's all. From next time, in the next video, we'll talk about how to transfer these areas on two-dimensional plane. Okay, how to go about it. Okay, so thank you.